Good morning, everyone. This is February 19th of 2025. We had a Zoom class today, but people either didn't wake up or had a hard time getting logged in. So I'm making a recording to remind you what we did during that Zoom class. So this was our web page for today. Since it was kind of a snow day, I decided to just go ahead and do choice seating. That's just a little joke. Anyway, so what we did was I reminded you that we did that mole vial lab last Thursday in class. If you didn't turn that in, it needs to be turned in. Most people in first hour got it in, but fifth and seventh hour, not as many. So don't forget to find that and be ready to turn that in on Friday. I want to do a little quick review of the mole basics and then do some sample problems, and then we worked on a new assignment. So let's get right to it. Here's the mole basics. This is a hard copy that I gave you in class. It's also posted in Google Classroom right here, mole basics. And also, since I'm sitting right here with the Google Classroom, if for some reason you lost your data for the mole bottle lab I was talking about a minute ago, here's some sample data that you can use. All right, so here's our mole map. Mole has three definitions. 6.02 times 10 to the 23rd thing, just like a dozen is 12. A mole is 6.02 times 10 to the 23rd. The more practical definition is the gram formula weight of something, which is the formula weight added up. And we did the strange names with masses quiz. Hopefully, if you've got, I haven't input those grades. If you haven't done that, be sure you use this time to do that today. And then we have 22.4 liters of gas, and we haven't done any problems with gases, but this new set has some on it, so I'll show you how to do that. Any of the above definitions can be used in equivalencies as part of conversion factors. And remember, when a conversion factor, the top and the bottom have to equal each other. And as long as they do, then it equals 1. So really, we're just multiplying by 1 like we did in August. With the mole map, if you're starting with particles and you want to get to moles, you're going to use this number, or vice versa. If you want to go from moles to grams, you have to use the formula mass, or vice versa. You still use the formula mass. For liters, you use the 22.4. So let's just jump right into a couple problems here. We'll just start with this one. Got how many atoms? No, let's start with an easier one. Take it back. So what's in mass in grams of 3 moles of water molecules? So you'd write down over here, I got a little piece of paper. So you have 3 moles of water. It says water molecules, but it really just means 3 moles of water. And we want to find the mass in grams. So you go back to the mole map. You're starting here with moles, so you have moles, and you want to get to grams. So you put your unit that you want to get rid of on the bottom, just like we've been doing multiple times before, and we put what we're looking for on top, grams of water. So since we're starting with moles and want to go to grams, it's going to be a one-step problem, and we have to use the formula mass of water in our conversion. You don't need to show this, but to find the formula mass, you're going to have 1 times 2 and 16 times 1. Those numbers come from the periodic table, which I thought I had sitting right here. Maybe not, so let's pull the periodic tables right here. So you see oxygen is 16 and hydrogen is 1. And that can be found, of course, right there on the website. All right, so 1 times 2 is 2 plus 16 times 1, so we're really looking at a total of 18 grams, and that's 1 mole. Moles cancel. 3 times 18 is 54 grams of water. So that's all there is to it. That was a one-step problem. There are 22 of these problems. I just did one of them. You're going to number them on a piece of paper like this. You would write down, this is number 21. So you would have written number 21 right there, and then do the problem. Now you have 21 to go, because we already did one. You can count this one. All right, let's take a look at another question. This one is, we got 40 grams of argon. We're trying to find volume. And so we write down number 19. And again, you're going to put these on a piece of paper. Usually I have a template for these, but the template, since we're not at school and not everybody has a printer, I didn't post the template. All right, so we have 40 grams of argon. You write down what you're given. 40 grams argon. Let's go back over here. We have grams. We want to get to volume. So look back at the mole map. We have grams. We want to get to volume. Volume's down here. So we're going to have to go from grams to moles. and then from moles to liters. Once again, you have grams. It does give us 40 grams, so we're right here. We're going to go to moles and then to liters. So on the way to moles, we're going to put grams on the bottom. So grams of argon, because whatever's here goes down here. Moles of argon on top. The number that always goes with moles is 1. We have to look up what the formula mass of argon is, so let's do that right now. Oh, that's not where we look though. We go here, and argon's on the right side. It says 39.95 right there. So we're going to go to, we'll make it 40. So we put 40 grams of argon right there. This one, these two numbers happen to be the same. That's coincidence. Next thing we're going to do is change to liters, because the question says, what is the volume? So to change to liters, we're going to use this conversion factor right here. You're going to put moles of argon on the bottom. You're going to put liters of argon on top. And 1 mole is 22.4 liters. So that's the nice thing about liters or particles. The numbers never change. When you're going to grams, you always have to add up the formula mass. All right, so our answer here would be 22.4 liters of argon, because you have 40 times 1 times 22.4 divided by 40. Really, the 40s just canceled out, as well as the grams of argon. Moles canceled out, so all you're left with is that 22.4. But you multiply all the numbers across the top, so this number times that number times that, and then take that answer and divide by every number that's on the bottom. So in this case, there's only one number on the bottom. All right, do one more problem. So you'll click over here, 22.4 liters, and you'll get a smiley face to show you your answer was right. All right, now let's go to our moles. Let's do another two-step if I can find one. Here's one. So you got 27 grams of water, and you want, no, that's a one step, never mind. Mass, that's a one step. Molecules, moles, one step. Here we go. 1.5 times 10 to the 23rd atoms of argon. We want to know liters. So we write down, this is number 15. And once again, how many of these are you going to have? 1, 2, 3, we've got 3 now. You'll have 19 more to go. So 1.5 times 10 to the 23rd liters. No, atoms. Atoms is what we're given. And that's atoms of argon again. Argon's a popular gas. That's what you are today, you argon. And then we have atoms down here, so it goes down here, so we can cancel it out. We already know that without even having to think. All right, now, we want to know volume. We've got atoms. Let's look back at our mole map. We're starting with that. Atoms are over here. They're particles. We want to get down to here. So we're not going to use the formula mass at all in this one. You just go from here to here, here to here. So step 1, step 2. This is a two-stepper. The two-steppers are really popular in Texas. I don't know if I mentioned that before. You know, the Texas two steps. So we go from molecules to moles and moles to liters. So let's do it. Moles on top. 1 always goes in moles. Number of atoms in a mole. It's 6.02 times 10 to the 23rd, but the numbers will work better on this activity if you just use 6. So we'll round it off to 6 times 10 to the 23rd. Then we just keep going because we don't want moles. Right now, if we worked it out, we'd have moles because we've gone to the middle from here to here. Now we need to go down to liters. So just keep going. Whatever's here, down here, so it cancels. Liters of argon on top. 1 always goes to moles. And how many liters are there in a mole? 22.4. All right, I'm going to work this one out on a calculator. So if you go over here, you just do a search here for calculator. Like that. So we're going to have 1.5 times 10 to the 23rd. So 1.5, and then use the EXP button, 23, multiply by 1, but 1 is just the same thing, so I'm going to skip that. Multiply by 22.4. That gives me that number, 3.36. This E means times 10, and that's to the positive 24th power. We have to divide by the number on the bottom, so we're going to divide by 6, and then the EXP again, and this time 23, right here. equals, final answer, 5.6. So we would get 5.6 moles have canceled. Atoms, of course, canceled already, so we have liters of argon left. Then you go back to your answers, and 5.6 is one of our choices, and say okay, and we're doing real well. We got 100%. All right, so that's how you do it. That's what we did in class today. So your homework is to review Google Classroom, make sure everything, you have everything in, including this assignment. And this assignment has to be shown on paper with work shown in this format. Let me say that again. The work must be shown in this format. It needs to look like mine does, in this format. So don't forget to show your work in this format. That is what it's going to take to get credit for that. I'll hand it back to you if you don't. So be sure you do it this way. Be reasonable. Do it my way. All right, that was our class for today, and I'm going to post this on in Google Classroom. Thanks.